Okay, hi pre-cal honors. So today we are going to do some simulations on the calculator. With parametric equations. So I am going to start by just giving you a famous example. I'm not actually even going to tell you what I'm doing at first. I'm just going to show you the simulation, and then we'll talk about it. How we made it all happen, all the magic, right? We could talk about that then after I show you the. Okay, let me fix the screen here. All right. So for this example, okay, we have, again, famous example, Lois and Superman. Lois is driving from Metropolis at an average of 65 miles per hour. 3 hours later, Superman learns, oh no, there's a bomb in her car, set to go off in 2 hours. If Superman flies at 155 miles per hour, can he save her in time? So again, I set it all up. So here goes, everyone. So what you're going to see when I hit graph, you're going to see Lois. She's driving her car, okay, and then Superman is flying above her. Here we go. Are you ready for the excitement? Okay, so there's the impending doom. Okay, maybe I should have had her drive a little faster. Okay, so impending doom is the black line, and Lois is driving towards it to get the scoop. Okay, Superman says, oh no, Lois is in trouble, and he's flying. And does he make it in time? Oh my goodness, no, he does not. Okay, well, let's see what happens. Okay, so first of all, if we think about Lois, okay, let's do some algebra. So Lois, we're thinking distance equals rate times time right now. Okay, so her distance is rate times time, 65 times t. If we say t is time that Lois starts. Okay, and again, these are parametric equations. So this is actually quite arbitrary. We're going to put her on y equals 2, that horizontal line. Okay, now when we do Superman, okay, so we're going to do distance equals rate times time for him. He flies 155 miles per hour, and his time is t minus 3 because, again, he started 3 hours later. Now, again, quite arbitrary. Y2, we're going to make it 3 because, again, he's Superman, he's flying. So he's going to be on y equals 3. He's going to be higher than her. Okay, so if you take a look at my equations, that's what I typed in. Now, the impending doom, okay, the doom. I wanted the doom to be at 325, but again, let's do some algebra. So the bomb explodes after Lois has been driving for 5 hours. So Lois has driven 325 miles when the bomb explodes. Okay, so I made the doom at 325. And notice that, again, the y is quite arbitrary. I just wanted to have a vertical line. So I just said 50 times t. I didn't really care how long that line was. I just wanted to make sure that the doom was at 325. Now, notice I was clever enough to have it stop, all the action stopped when the bomb exploded. And again, maybe we should watch that again. So I could, here, I just kind of typed over something here so we could watch the graph again. So again, here comes Lois, and while that's working, I'll go ahead and talk and say, well, I wanted you to see, what happened at the end. So I realized that, let's see. So I wanted to figure out when to stop. So again, I stopped at 5 hours. Okay. So let's look at the window. So I let t be 0 to 5. And again, the t step was kind of arbitrary. I just wanted to make sure that it didn't go too fast or too slow. And then I had the x max at 350 so that you could see everything happen since the doom was at 325. So let's think about this. We know that Superman didn't make it. So for the next question, it says, how fast would he have to fly to save her in the nick of time? Well, Superman has 2 hours to fly 325 miles. So 325 equals rate times 2. His rate would have to be 162.5 miles per hour in order to save her just in the nick of time. All right, great example. The only other thing I should probably mention is in mode. Yes, we were in parametric mode, but also I changed it to simultaneous mode. If you cursor down, I changed to simultaneous. Oh, went too far. Simultaneous mode because I wanted all the actions to happen at the same time. All of um, the Superman and the Doom and Lois all got graphed at the same time. Otherwise, it wouldn't be very exciting. So great job, everybody.